Okay, let's have a look now at composite functions. We've talked a little bit about functions now, and we've looked at what actually defines a function, what's the difference between a function and a relation. So hopefully that's okay. The vertical line test that gets you through there. Looked a little bit at domain and range. Really important that you understand that the domain is the value of the x values that fit a function, and that the range are the y values that fit a function. Often a graph really helps you there determine what the domain and range are of functions. So we move now into function notation and composite functions. I want to talk about this concept of composite functions today. Really quite a neat little concept. But first we need to understand what function notation is. And what I've written here is that f of x, this thing here, we say this as f of x. That's just sort of how we say it. What it means is, it means the value of the function at this value of x here. So we see functions defined in this way. So a function of x is defined as, right, let's say it's 2x plus 1. Right, that's it. That's our function of x. Now we can, it doesn't have to be an f, it can be a g. gx, it can be an h or an I or whatever. G of x, we use f most often just because f's a function. But we can say gx equals, let's say, x squared. So what we've got here are, we can have lots of different functions defined in different ways. We use a different letter for each one. But what this says is that I've got a function that's defined that whatever value I've got for x, what we do is we double it and add 1. That's what the function does. The function is like a machine. You put in the value of x, times it by 2 and adds 1. So if you like, if I've got a value, all right, if I want to find out what the function value is at 2, then really what I'm doing is I'm taking a value 2, I'm putting it into my function, my f function, okay, because this is f of 2. So I'm putting it in here, f of 2. So I put it in my f function. Actually, I didn't need to really write that like that, did I? I just write it as, put it into my f function. And what happens is that the value of this function when x is 2 is twice 2, 4, plus 1 is 5. So what punches out is 5. So the input value is 2, right? That's my input value, f of 2. And my output value is 5. So f, the function value at 2, the value of the function at x equals 2 is 5 for f of x. I could say, what's g of minus 2? Well, that's like taking minus 2, putting it into my g machine, my g function, and the g function, the rule is that whatever goes in gets squared. So minus 2, you square it, what pops out is the output of 4, so g of minus 2 is 4. So think of this in brackets as the input value, what goes into the machine, and this value here is what comes out the other side after the machine and the function have done their work on it. Okay, so that's how function notation works. Now when it's f of x or g of x, that's just announcing what the rule is, the general rule for x. What's happening to my x is that it's being doubled and added 1. What's happening to my x in the g machine is it gets squared. So whatever goes in gets squared. Whatever goes in here doubles and adds 1. Okay, hopefully you understand that a little bit better. And this is our function notation, f of x. Okay, so I'm here in this lesson to talk to you about what's written here, and that is composite functions. All right, so let's take another little note here of composite functions. Now, what composite functions do, they look at taking multiple functions and taking values from one function and inputting them into the other function. I'll show you what I mean. So composite functions. Let's have a look at evaluating. I'll just say evaluate. Let's see, evaluate. So this is an example. Evaluate the function of g2. So what this is now a composite function, because I'm not just saying give me the value of this function at a certain, I first need to find out this value of g2. So this is what we're doing here, is we're we're looking at multiple functions. So what we're doing in this instance, we're taking the value of 2 and we're firstly putting it into the g function, right, because we're finding out what g2 is. So we're finding out the value of 2 in the g function. Now the g function says that whatever you've got, you have to square. So the input value of 2, the output value for once it's gone through the g machine, will be the square of 2, which is 4. Now we take the 4, so this here is g2. Now we take the 4 and we put it through the f function. Right, now that, in effect, what we're doing there is we're taking f of g2. Right, now if you put 4 in the f function, so you're taking the output from the g function, 2 goes into g, the output's 4, now that bounces into the f function. The f function has this rule that says, whatever goes in, double it and add 1. Alright, so my f function, double and add 1, I've got a 4, double it and add 1 is 9. So f of g2 is 9. Now, often how you see this written, well, this is how you see it written. You see this little circle here, FOG, it looks like fog. All right, you'll see it written like this, fog 2. And that's what it means. When you see this little circle notation here, this is a composite function notation, and it just means, all right, this in this order, f of g2. So I need to take my 2, put it through the g machine, see what the output is, then put it through the f. Okay, so if we have a look at another example of how this composite function works, let's look at trying to evaluate, let's go the other way and go g o f of minus 3. Let's see how we go there. So what that means is we're going to take minus 3. If you like, so this is what this GOF means. It means find the g of the function of minus 3. So let's work from the inside out. So what that means is we take a minus 3 and we put it into the f function. Now the f function says, what does it say again? It says, the f function says double it and add 1. So twice that, minus 6, add 1, gets me minus 5, which we now put into the g function. All right, the g function says take my input and square it. So input minus 5, square that, 25. So my g of f of minus 3 is equal to 25. Okay, let's do another one. This time I'd like you to, let's define another couple of functions, right? So let's let f of x equal, right, so this is another example. Let f of x equal 4 minus x, and g of x equal x squared plus 2. All right, now find, let's just go for f of g minus 1. Okay, so I'm going to ask you to pause the video here and try this example out for yourself. Okay, so now what we do is we rewrite this because I think it's more useful to see it written like so. Now what that means is we take minus 1 and put it through the g function. So we find g of minus 1. Now g of minus 1, we put a minus 1 in here for x. We square it. We get 1, we add 2, we get 3. So what we now need to do with that 3 is put it into the f function. So the output from minus 1 in here is 3. In it goes to the f function. F of 3, 4 minus 3 is equal to 1. So there's my solution there. I'll give you another question. We might this time go for FOF of 2. So what this means is that we're going to take 2 and put it through the f function to get an output. All right, so we put 2 in here, we get 4 minus 2 is 2. But then we take that output and put it back in the f function. So we get so we put 2 through and get 2. So we evaluate there. Now we put 2 back into the f function. 4 minus 2 is equal to 2. So we can have this iterative process. All right, the last one I'll give you is, well, might be GOF of 5. All right, pause and have a go at it. Okay, now the solution here is we take the function value of 5 and put it through here. So 4 minus 5, we get minus 1. So then we take minus 1, put it into the g function, we square minus 1, and we get 1, and add 2 is 3. So hopefully that's matching up. What is, and now this is, we're just going to have a look at finding FOG of x. So in this case, what we're just going to do is we're going to have in terms of x. We're not going to be able to evaluate it. We're not going to get a numerical answer. We'll get an algebraic answer. So gx, now gx is just x squared plus 2. So in this case, we just want to find x squared plus, so x squared plus 2 goes into the f function. Do you see we haven't got a numerical value here, so we can't find the numerical output. It's the algebraic output. When we put x into the g machine, well, we just get x squared plus 2. So now we're going to take x squared plus 2, and we're going to put that into the f machine, which is 4 minus x squared plus 2. So that's how we're going to evaluate this. This is 4 minus x squared plus 2. So when we just take down the bracket, it's 4 minus x squared minus 2, which is equal to 2 minus x squared, and that's my f of gx. I might just leave you g of fx to work out. If you can pause the video and do that, and we'll check on your solution in a moment. Okay, ready to compare answers. All right, that's g of fx. So what we do is we just take the fx as it stands, 4 minus x, and we put it into the g. So what does the g machine do? It takes any input, squares it, and adds 2. So what we need to do is square 4 minus x and add 2. All right, let's see how we've gone here. Just do a little expansion. Minus 8x, you can see how important that algebra is we were talking about yesterday. And add 2, and then we just tidy it up. X squared minus 8x plus 18, and that is my g of fx. Okay, plenty more practice in exercise 1F when you get round to that. For the next 2 days, I am on duties elsewhere, so I won't be able to be in class, but it'd be great if you can get up to exercise 1F and do any work over the holidays that you think would be useful. And I think the grounding in algebra is so important. So if you need to do some more work there, get in touch with me. I can send you some practice exercises to do. Okay, cheers.